Okay, so let me, again, I'll just use version 18. Alright, so let me Alright, so I've got two geometries here. So let me link a static structural to the geometry. So I don't want to do anything to the geometry. So here I'm going to edit. And this opens up the mechanical window. Alright, so this is basically an upright. So this is from one of the workshops on the LEAP academic portal. Okay, just trying to arrange it so you can see it. Okay, so you can see it's got quite a lot of detail. So we've got the areas for the bearing to go in, and then there's faces for where the brake caliper mounts, and then you got your upper and lower pickup points. So if I look at the geometry, there's just one part. So we'll talk a bit more about this when we look at actually doing an analysis. So at the moment what we're concerned with is getting a mesh on there. So I don't do anything and I just say generate mesh. So it goes away and creates a mesh on here. So this is a very, very coarse mesh. So you're not really going to get any meaningful results out of this. So you've only got one element spanning across that entire face, and that's not going to be enough to capture the stresses for this structure. So you might get good resolution of displacements, but definitely not the stresses. So the most elementary control we can do is we can, so let me just change this to uniform. Let me generate mesh again. So I probably won't change it all that much. So we've got another element across there. Okay, so you can see it's even deviated from the geometry there. So that's the face, and the elements are sort of deviating away from that. Okay, so what I'll do is so there should be an element size somewhere here. Okay, so what I'm going to do, let me just insert a sizing control. So I select the whole body. So the default size it's trying to use, so if I move my mouse in, so that's even bigger than that hole there. So if I compare that to the step size, you can see that that's way too big, so it's probably going to start defeaturing that away. You can see that little feature there that let me highlight it another way. that little dimple there, that might be important in terms of the structural strength, and that's not captured properly by the mesh. So you can see it's created the wrong sort of shape there. Alright, so if I go to the sizing, so here let's say use a size of 3.5. As I move my mouse in there, you can see that's the size of element that it's going to try and create. So let's generate that that mesh there. Okay, so you can see that that's it looks visually like it's much closer to the geometry. So circles are resembling circles. So in here maybe we need a few more elements, but we can handle that with some local controls. So especially around the pickup points, we want to make sure we've got good resolution of the mesh, because that's where most of our stresses are probably going to be, because that's where the loads are concentrated. So we would expect there to be we would expect to need more elements around that area. Okay, so we make sure we click on the mesh branch, so then when we select something, so here I'm on face select. So let's say for example on these fillets here I wanted a finer mesh. So here if I right click, insert sizing, so let's use a size of 1.5 around there. Okay, so that'll go and generate the mesh, and it will put a fine mesh in that area, and it will transition away in other areas. Okay, so let's have a look at the metrics, or how good this this mesh is. So if I change the display style, so let's change it to element quality. So you can sort of see as a contour where the good and bad elements are. So because this is a solid, we can't really see what's going on inside the model. So there's another way we can look at this. So if we go to expand the quality in the details of mesh. So here there's a mesh metric. So if I switch this to element quality, so down the bottom here you get a bar graph. So if I click on those bars, if I hold control, that shows me where because there's a lot of good elements in here, but there's not so many bad ones. But these bars are obscured because of the scale here. So if I go to controls, if I make my maximum quality 0.4, because remember I said 0.4 or above is what I'm aiming for. Okay, so I just reset the y-axis. If I close that there, so now I can see where my really bad quality elements are as I highlight these areas. Okay, so possibly around this area here, and that area there near where the brake lug is, or the lug for mounting the brake caliper, they're probably going to be areas that I'm interested in. So I probably need to address those areas. Okay, so let me switch to aspect ratio. So again, the low ends are obscured. So let me change my controls. So minimum, let's say 4 and above. sorry, let me reset the y-axis. Okay, so if I try and zoom in on these areas, so it's a bit hard to see because it might be jerky, but you can see that that element's got a very, very small face, and then there's an adjacent very, very large face. If I rotate it around, there's another, just where that ball is, there's a small face and another large face. Okay, so that's, there you can see there's a very large difference in the areas of those faces, and it's also the edge lengths that have got a large difference there. So in order to get a good aspect ratio everywhere, if you use a very, very small element size, that's going to allow you to get good aspect ratio elements. But you don't always want to do that. Okay, so if we go to the statistics, this tells me how many nodes and elements are in the model. So the number of nodes in the model gives you a rough indication of the mathematically speaking, the size of the problem that you're trying to solve. Because remember, I talked about earlier with the two-spring model, you're solving a set of simultaneous equations. In that case, it was only two simultaneous equations. So here we have, let's just call it 100,000 nodes. At each one of these nodes, you've got to solve displacement x, displacement y, displacement z. So that means you've got 300,000 displacements you've got to solve for, or 300,000 unknowns. So if you think of solving a matrix equation of 300,000 unknowns, you've basically got a matrix that's 300,000 by 300,000. So then if you've got any fixed nodes, they will automatically drop out, so it reduces your problem size slightly. But this is a very, very good way of getting an indication of how big your model size is. So something like this will solve fairly quickly. It's only when you start getting up to say 2 or 3 million nodes that your model might start taking a little bit longer to solve. So hopefully you've got access to fairly powerful computers. So something of this sort of size would probably solve in under a minute. So don't quote me on that. When we actually do the structural simulation, we'll see it. So the solve time will differ depending on how powerful your computer is. All right. So back to the meshing controls. So if I wanted to get a good mesh just in this sort of area here where I'm circling, or where I've got the red dot, that might be a bit easier to show. So because it's one solid, it's not a single step process. So what I'm going to do is I'm going to select the cylinder of that hole, and I'm going to create a coordinate system there. So I'm going to use this coordinate system to help me assign a mesh control. So I'm going to do another one up here as well. Okay, so now if I go to mesh, and if I say insert sizing, so I'll select the entire solid. Okay, so here I want to use what we call a sphere of influence. So here I've got to get these extra inputs that I need. So I need a sphere center. So that's what I created my coordinate system for. So the radius of the sphere, 50 millimeters is probably too big. So I'm just experimenting here. So 25 millimeters, and the element size I might, let's say, make 1 millimeter. So if I zoom in, Anywhere inside, anywhere where that sphere intersects with the solid that's coloured blue, or I could just as equally have done that on the faces, we'll get assigned an element size of 1 millimetre, and then it will transition away from that 1 millimetre anywhere away. So because that's breaking through on the other side, it's going to put an element size of 1 millimetre through the solid. Okay, so if I update that, or update the mesh, okay, so you can see it's created a very, very fine mesh in that particular area. Okay, so what I'm going to do, I'm going to use a slightly different approach for the other sphere of influence. So here I'm going to right click, insert sizing. So here I'm going to choose the faces. Okay. Alright, so again I change it to sphere of influence. So the sphere center, so I choose the second coordinate system. So you notice the little pointer that I've got there. So that's the where it's going to put the center of the sphere. So the radius of the sphere, so let's use, 30 millimeters looks big enough. And element size 1.5. Okay, so it's got, okay, so it's giving me an error there. So here if I show message, alright, so let me just change that to adaptive. Okay, so sometimes the messages are very cryptic, but in that case it was fairly straightforward and it told me what I needed to do. Okay, so once you have a base mesh, so you can also use what we call a refinement. Okay, so if there's areas that you wanted to locally put a fine mesh on, so areas like this where you've got sort of small curves or radiuses. So generally you want to have more elements around those rounds. So there was only like 3 elements across there, so you probably should have a little bit more than that. So let me include these faces here as well. So if you select the faces first and then if you right click, insert, it filters out what it is you can and can't apply. So here it shows me the only things that I can apply. So here if I do a refinement, so if I do a level 1, it splits each of those edges once. Okay, so if I generate the mesh, so it sort of splits the edges, then it transitions away. Okay. All right. So let's look at another control that might be useful, particularly here where we've got bolt holes. Okay, and that's what we call an inflation. Okay, so if I do inflation, so for the geometry, I'm going to choose the solid. the boundaries of those two faces. So what an inflation does is it basically takes elements on the surface and then it sort of sweeps those inwards to create concentric rings of elements. Okay, so here I'm going to tell it how many, sorry, I'm going to tell it the total thickness. So if I put in a thickness, I can see how that will manifest, or how thick it will go. So if I zoom in, that's how far the inflation is going to go. Okay, so if I generate the mesh, oh, there was something else I forgot to do on there, so let me just see if this actually works. Okay, that hasn't quite worked. All right, so there's a growth rate here, so that should really be 1. Maybe let me do 4 layers. Okay, so here, so it's giving me an error, so let me see. Poor quality elements. And then there's a warning here as well. Okay, so I think because that face, hopefully that's not more than 5 millimeters. Let me try again. So you can see it partially worked because it's got two layers of elements there. Okay, maybe that wasn't a good area to do my inflation on. Let me reduce the thickness there. And also let me do a face sizing on there. Okay, so that's still failed. Let me get rid of the refinement. That's what's causing the error. Okay, so it was a refinement all along, I think. So you'll notice how it's got the concentric rings around there. So that might be important for resolving stress gradients sort of close to bolt holes and things like that. So that's a way of sort of getting just sort of local controls. So other things we can do. So let's select these edges. So if we wanted a certain number of elements around those edges, So I can do a size, or I can do a number of divisions. So you can see it's visually, it's showing me a visualization of what the gap sizing is going to look like. Okay, so there's a behavior here of soft or hard. So if you do it as soft, depending on the surrounding elements and the surrounding mesh size, it may or may not be able to apply those controls. So if we do hard, it has to do those controls no matter what. So if it results in a failed mesh, that's what will happen. But in this case, it shouldn't be too different to what's around there. Okay, so you can see how I've changed the mesh around that area. Okay, so there's a lot more things you can do with the meshing. So it's very hard to sort of show everything on one geometry in a short 5 to 10 minute demonstration. So this is just to give you a bit of a teaser for what is possible.